When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still, 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the sun heating up and getting denser. As a result, the sun would get way larger than it is now. During this transformation, the sun would swallow Venus, Mercury, and Earth. Picture this. You're planning your dream holiday, but instead of going to a tropical beach or a bustling city, you're thinking about going to space. Imagine yourself floating, weightless, looking down at Earth from a whole new perspective. The beauty and wonder of our planet become even more evident when you're viewing it from a distance. And now, this dream can come true. Yes, you heard that right. Space tourism. Space tourism is something that has fascinated people for generations. This idea has been around for almost 20 years. We've seen it in movies and read about it in stories. But now, thanks to advancements in technology, it's finally becoming a reality. The first space tourist was a businessman named Dennis Tito. He visited the International Space Station in 2001. Sounds incredible, but here's the catch. Tito's trip cost a mind-boggling $20 million. That's a lot of money, and it made space travel seem like a dream that only the super rich could afford. And it's true that space tourism can be quite expensive. But a lot of time has passed since that day, and now space tourism is becoming more attainable for people who aren't billionaires. Of course, the industry is still in its early stages, but the demand for it is skyrocketing. Pun intended. Experts believe that it will continue to grow at an incredible rate of around 40% every year from 2023 to 2030. So, with all this in mind, let's talk about what awaits us in the near future. There are different types of space tourism. First up, we have suborbital spaceflight. It's the trip where you reach an altitude of over 300,000 feet, which is way higher than any airplane can go. In fact, it's so high that you cross a special line called the Kármán line, which marks the boundary of outer space. How cool is that? So it's basically like a quick jump into space and back. So let's talk a bit more about suborbital spaceflight. Imagine you want to go on vacation to Sydney. but you live in London. Normally, it would take you about 22 hours to get there by plane. That's a really long time to sit on a plane. But guess what? Scientists and engineers are working on a new way of traveling that could make the journey from England to Australia super fast and exciting. Suborbital space trips could be used for quick travel between different cities on Earth. Instead of flying in a regular airplane, you would hop on a spacecraft that can go really, really fast. According to a recent study, in the near future, it might be possible to fly from London to Sydney in less than 2 hours. Just imagine how amazing that would be. You would zoom up into space, see the Earth from above, then come back down in no time at all. What an adventure! This study, conducted by the UK's Civil Aviation Authority, was all about understanding how our bodies react to trips outside Earth's atmosphere. To figure this out, the researchers needed some brave volunteers. They recruited 24 healthy people between the ages of 32 and 80. These volunteers were taken to a special training facility called an RAF centrifuge in Cranwell. A centrifuge is a big machine that looks like a giant spinning chair. The volunteers were sat in there to experience a simulation of spaceflight. They were spun around, and their bodies felt the pressure and changes in gravity that happen when you go into space. Almost everyone handled the simulation pretty well and quickly returned to normal. One person even briefly lost consciousness, but it was because of the gravitational forces, and they recovered soon after. Now, this study found some surprising things. Many people think that you have to be really fit and young to handle space flights. But the research showed that older people can actually cope better with all this gravity craziness. So even if we don't develop space tourism in the next decade or two, you'll still have a chance to visit space, even when you get old. Right now, there are two big players in the suborbital spaceflight game: Virgin Galactic and Blue Origin. Both of these companies have rocket-powered systems that can take up to 6 passengers on a thrilling ride. Virgin Galactic has already had 4 successful flights, but they recently ran into some financial trouble. On the other hand, Blue Origin has flown 32 passengers on their new Shepard rocket. The catch is pretty obvious. Right now, space tourism is super expensive. Companies can charge a whopping £350,000 per seat for these flights. But don't worry, things are about to change soon. Experts believe that space tourism will grow in the coming decades. It will be kinda similar to what happened to airplanes. Right now, the cost of a quick trip to space is very high. But as time goes on, the prices will go down. Eventually, space tourism will become more affordable and accessible to people all around the world. That means not just our children, but many of us will have a chance to experience the wonders of space. As technology advances, we might even be able to plan rocket-powered holidays in the future. Can you imagine telling your friends that you went on a vacation to space? What a flex! And now, let's talk about orbital spaceflight. This is the real deal, where you get to spend more time in space. Instead of just a few minutes, you can spend anywhere from a few days to over a week up there. And we're not talking about a measly 300,000 feet anymore. We're talking about going over 1.3 million feet high. So whether you're up for a quick jump into space or a longer adventure orbiting our planet, space tourism has something for everyone. Sky is no longer the limit. But space tourism isn't all fun and games. There are some challenges we need to consider too. First off, let's talk about the environment. Launching spacecraft and rockets takes a lot of energy and can create air and noise pollution. This can seriously harm our atmosphere. We don't want to trade a cool space trip for a damaged planet, right? Next, there's the issue of safety. Space travel is still risky, and accidents can happen. Even with safety protocols in place, there's always a chance of something going wrong. And if it does, the consequences could be really, really bad. Yikes! Space debris is another concern. Every time a spacecraft is launched, it leaves behind debris that can stay in orbit for a long time. As more launches happen, the amount of debris keeps growing. This can cause problems for other spacecraft, and even small pieces of debris can cause damage. Space travel also requires a lot of resources like energy, fuel, and materials. Using up these resources too quickly could have long-term consequences for our planet and future generations. We need to make sure we're not depleting everything in our quest for space exploration. Oh, and let's not forget about all the legal stuff. The rules and regulations for space tourism are still evolving, and it's not always clear who should be responsible if something goes wrong. Plus, there are concerns about how space tourism might affect international space laws and treaties. We don't want legal chaos in the final frontier. And finally, to achieve our dream of taking spaceships like planes, we'll need better infrastructure and logistics. We'll need to build more spaceports where spaceships can take off and land. But don't worry, scientists are actively working to solve these problems. Remember, it's not just us who are excited about space tourism, even governments are joining the fun. Many countries are investing in space tourism too. It's a global phenomenon. So even though there's still a lot to develop in this industry, it's pretty obvious that the aviation industry might go through a big revolution. Traveling long distances would become much quicker and more exciting. And judging by the way development is going, the first big breakthrough in this area will be made in North America. So, get ready for a new era of travel. What an exciting time to be alive, right? The universe is calling, and it's time for us to answer. Stay tuned!
Imagine a planet where every breath you take electrifies your body like a shot of espresso. The sky above you is an intense shade of blue, while colossal trees stretch towards the heavens, their vibrant green leaves growing at an astonishing rate. Daily exercise becomes a thrill like no other. With the abundance of oxygen, you become a supercharged version of yourself. Running feels effortless as you dart across the landscape, lifting weights that would normally seem impossible. It's as if the world itself is infused with a surge of energy. Everything is moving faster. The wildlife surrounding you is equally affected by this oxygen overload. Animals roam the land in majestic proportions. Their massive frames are propelled by speed and agility. Picture yourself in a pulse-pounding chase with an oxygen-charged cheetah, racing against a predator that could put a Ferrari to shame. Now you may wonder how such a wild scenario could ever be possible. Well, let's see. Oxygen is the powerful fuel that keeps life going. It makes up about 21% of the air we breathe, and every breath we take delivers these tiny molecules to our cells, giving them the energy they need to thrive. Without oxygen, our cells would struggle, and our bodies would fall apart. But that's not all. Oxygen is a superstar that works for all kinds of living things, from tiny bacteria to giant elephants. It's even important underwater, where it enriches the oceans. Amazing creatures like plankton and algae produce lots of oxygen, creating a thriving underwater world. But to fully understand the impact of high oxygen levels on the planet, prepare for a journey back in time. Recently, scientists have made an astonishing discovery. They tested rocks from two different places that were really far apart. And can you believe it? These rocks held tiny pockets of gas that showed how oxygen levels shot up by almost a third in a very short time. It was like a breath of fresh air. So they studied these rocks and found that oxygen levels back then were much higher. Imagine lush landscapes, towering forests, and gigantic swamps that stretched as far as you could see. During the Carboniferous period, oxygen ruled the atmosphere at an impressive 20%, just like today. But over the next 50 million years, its levels shot up to a crazy 35%. Can you imagine what that did? As oxygen surged, something incredible happened. Huge forests grew all over the land, creating a breathtaking green world. And massive swamps took over low-lying areas, making the landscape look surreal and otherworldly. At the same time, carbon dioxide levels dropped. Normally, when things break down, microbes release carbon dioxide into the air. This gas acts like a warm blanket, trapping the sun's heat and raising temperatures. But in the mysterious swamps where these giant plants were buried, the microbes couldn't do their job. The result? The planet got really cold. Who would have thought that a breath of fresh air could have such power? The scientists are still trying to figure out why this happened. But one thing is certain, it wasn't just happening in one place. It was a worldwide phenomenon. It was like the planet was playing a funny game with the climate. But let's go even earlier. We see the first North American dinosaurs making their grand entrance. High oxygen levels are what gave a big boost to the rise of mighty dinosaurs in North America and beyond. Picture tropics filled with the magnificent giant creatures. Obviously, dinosaurs didn't just appear out of nowhere. They took advantage of a changing environment that was perfect for their evolution. Oxygen levels played a huge part in this dinosaur party. As oxygen levels rose, so did the size of these incredible creatures. They started small with predators like Chindosaurus, and soon after, huge dinosaurs like sauropods took over the land. Then, 65 million years ago, dinosaurs disappeared and mammals took over. And here's the interesting part. Mammals never grew as big as dinosaurs. So what's the explanation for this? Mammals, and humans are mammals too, by the way, are special because we can regulate our body temperature. But that comes at a cost. We need a lot of energy to stay warm compared to reptiles and dinosaurs. Dinosaurs didn't bother with temperature control, so they could focus on growing big. The biggest dinosaurs were 10 times larger than the largest mammals. It's like a game of anything you can do, I can do 10 times bigger. Dinosaurs might have had similar limitations with their sizes, but those were much less strict. Before the dinosaurs' extinction, mammals were very small. Many mammal species disappeared along with the dinosaurs. But survivors took advantage of the open ecosystem and rapidly diversified into various body sizes. However, after 42 million years of growth, mammals reached a size plateau. This happened on all continents, most likely because of the temperature and land area. Colder environments allowed mammals to grow larger. Balancing body size and heat became challenging. Land area also played a role in sustaining big populations. But making animals bigger isn't the only thing high oxygen can do. This humble gas is a true jack of all trades. It also acts as our loyal bodyguard, protecting us from harmful UV rays and other dangers from space. Without oxygen, we would be defenseless against space threats. Oxygen also has a fascinating role in shaping the weather. It teams up with its other atmospheric buddies to make the sky go wild with tornadoes, hurricanes, and thunderstorms. They mix and mingle in the air, creating just the right conditions for these exciting weather adventures to happen. And these adventures can be dangerous, but they serve an important purpose. They help distribute nutrients and organic matter, carrying soil, leaves, and debris to new places. So what if we decided to mess with nature and crank up the oxygen levels to crazy heights, 30%, 40%, or even 50%? Well, too much of a good thing can become dangerous. Oxygen toxicity is when too much of this gas causes big problems. It's like eating loads of candy. It's fun at first, but soon enough you'll regret it. Surprisingly, an overdose of oxygen can leave you struggling for breath, like a tired dancer in desperate need of a break. At first you might feel a burst of energy, but it doesn't last. Dizziness sets in, as if you've been spinning on the dance floor for hours without stopping. In extreme cases, too much oxygen can even harm your body, making you feel like you've crashed into a huge truck. So while oxygen is always with us, giving us life, it's important to appreciate its delicate balance. Don't put on your special breathing gear. Also, we wouldn't be the only creatures to suffer from this oxygen extravaganza. Mammals, for example, will struggle to adapt to these extreme levels. The balance of power among species will change drastically, and winners and losers will fight for survival in a world that's spinning out of control. And we'll need stronger shelters to deal with these gigantic animals. We'll have to stay nimble and avoid danger. Amidst all the chaos, there will be astonishing adaptations. Birds will fly higher than ever before, reaching heights that would amaze even the clouds. Also, get ready for more natural disasters and delicate ecosystems hanging in the balance. Fires will start quickly and rage fiercely, making wildfires a constant threat. Even a small spark from a campfire could cause disaster. We'll need to rethink our cooking and heating methods to stay safe in this oxygen-filled world. But let's not forget the other side of the oxygen story. If we had a planet with low oxygen, only around 15%, we would face a completely different struggle. Every breath would be difficult, leaving us tired and struggling for air. Physical activity would become extremely hard, and our memory and focus would suffer. So let's be grateful for the oxygen levels we have now. They're the perfect balance for us to thrive. In this exhilarating journey through an oxygen-rich world, we've experienced breathtaking wonders and discovered the delicate balance of our planet. Let's cherish the magic in every breath, respect the interplay of oxygen and life, and embrace the thrill of this remarkable ride called life. What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light-years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff, but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw 2 of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy, and even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much. because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate.
You know how it all started 13.8 billion years ago with the Big Bang? Bam! No, wait, I can do better. No, never mind. And the universe has been expanding ever since. At its young age, it was all made of gas, mostly helium and hydrogen. For billions of years, the gas has expanded and cooled down. Meanwhile, galaxies, stars, and other mysterious things in space we try to explore today formed because of gravitational forces. And in that chaos, just like in middle school, about 4.6 billion years ago, our magnificent planet was born too. It all started as a disk of gas and dust that orbited the young sun, just the same way it was with the rest of the planets in our solar system. This disk consisted of dust particles of different sizes and gas. They were circling the sun at different speeds and in orbits that weren't stable and predictable. They were bumping into each other all the time. These particles grew from very small grains of dust into boulders, then later into bigger objects called planetesimals that had a range from miles to hundreds of miles in diameter. And these planetesimals that were orbiting the sun within the disk had gravitational force strong enough to pull other objects from the neighborhood out of their orbits and collide with them. As they were constantly hitting each other, they got bigger and bigger until some got to the size of thousands of miles in diameter. That's nearly the size of Mars and the Moon. We know these things because of meteorites. They come from different places all over our solar system and bring all kinds of materials to our planet, giving us something cool to study and learn about our solar system and how it formed. These materials include very small pieces of dust and rock that have gone through the chaos and survived those rough times even before the planets were created. Meteorites also brought pieces of asteroids and planetesimals left behind after the planet-forming process ended. As these objects were forming, some radioactive elements were left trapped inside the minerals that, again, were part of them. That's how scientists could tell how old they were. But the final stage of Earth's formation, and generally this whole chaos that was happening in our solar system, may have taken a little bit longer, possibly even up to 100 million years more. That's when the last enormous impact was, and the Earth finally reached its full size. What actually happened is that it hit another object which was nearly as large as Mars. This collision was so strong that the impact produced enough energy to vaporize some of the metal and rock, both from the Earth and the Mars-sized object. And this vapor created a disk that was surrounding our planet. That disk cooled and clumped together at some point, which is when we got our moon. Our moon was the result of impact debris, which was a combination of hot gas and molten rock. There are some theories of how the moon formed, though. One claims it broke off from the Earth. Another one says the moon formed somewhere else in our solar system, and at some point, as it was wandering around, it got so close to Earth that it ended up captured by its gravity. And fans of the third theory believe the moon and the Earth formed at the same time, from the same protoplanetary disk. Before the moon formed, the Earth was a much different place. If you could have just one day on Earth without the moon, you'd be first surprised by the days and nights. They wouldn't be as stable as they are today because the moon helps to keep the Earth's axis stable. Days were shorter back then. The Earth had been rotating much faster before the moon formed. Its gravitational pull slowed the rotation of our planet, which means days got longer. The Earth's rotation is getting slower through time, but at a really small rate. Some predictions say that in 1 billion years, a typical day will be between 25.5 and 31.7 hours long. If 24 hours is not enough time for you, just wait 1 billion years. But yeah, if you're the type of person that likes to take things slowly, you definitely have to hurry back then. Although there weren't many things you could do back then than to fill your time besides, sailing across the hot lava, collecting rocks, or hoping not to get hit in the head by some fierce meteorite falling onto our planet. Ow! But if you were patient enough, maybe you'd see something really cool: water coming onto our planet for the first time. There was a rain of fiery meteors coming from the sky, and they kept slamming into our young Earth. It looked devastating at first, but some of this falling debris probably held water. Many believe the asteroids and comets that bumped into our home planet carried tiny amounts of water. But considering this meteorite shower lasted more than 20 million years, maybe even up to 200 million years, it's not that unusual that after a while, puddles of water started to collect across the surface. And as the water evaporated within the atmosphere, it would fall back down, forming lakes, rivers, seas, and eventually oceans. Only at that point, there was a chance for some primitive life to evolve sometime in the future. Earth started its transition from a hot ball of magma to the world we know today. Before that, it would be too hard for life to exist there. Even if it had happened somehow, all those meteor and asteroid collisions would have probably destroyed it. Also, you wouldn't be able to survive without an oxygen tank. The Earth did have an atmosphere, but it wasn't like the one we have today. Scientists believe it was composed of water vapor, methane, ammonia, and some other gases released from volcanic activity. Basically, it was too toxic, since there were volcanic eruptions all the time. And the temperatures were way higher, so just standing at these early stages of Earth wouldn't be such a pleasant experience. Also, there could even be some form of life at that time. In its early stages, when everything was so chaotic, it wasn't covered in oceans, trees, or stunning landscapes like today, but in molten magma. I mean, the earliest form of life we know about are fossils of microorganisms found in hydrothermal vents, and they're thought to be 1.4 billion years old. And scientists assume the earliest time for life to show on Earth could be 4.2 billion years ago, give or take. So, with the right equipment, you could even see some single-celled organisms, like bacteria, somewhere across our chaotic planet, even before the Moon was there. The Moon's gravitational pull on the Earth creates tides in the ocean, which means it probably helped mix and circulate ocean water, maybe even shape them. The tides without the Moon would be much smaller, because the gravitational pull is what causes the tides to rise and fall. The Moon also affects life in the ocean. Over time, animals in the ocean have changed and adapted to the changing water levels caused by the Moon's gravity. Even just the moonlight has a big effect on sea creatures. For example, corals use the Moon's cycle to release their eggs at the same time and with stronger tides to help carry the eggs. Baby sea turtles use the Moon's light shining on the water to guide them from their nests to the ocean. Who knows which directions life on the Earth would have taken if, at some point, billions of years ago, we didn't get our lunar buddy to follow us along the way.
Do you know what the third brightest object in the night sky is? If you said the International Space Station, you're absolutely right. And the coolest thing? You can sign up for a special service and you'll get a text every time the ISS is traveling over your location. And if it happens at night, you can see it with the unaided eye. But be quick, because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. If you moved at such a speed, you'd be able to make a round trip to the Moon within a day. At the same time, the ISS isn't the fastest human-built object. This title belongs to the Parker Solar Probe that travels around Venus and the Sun at a speed of 430,000 miles per hour. On the bright side, astronauts on the ISS see a sunrise and sunset 16 times every 24 hours. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view bay window. And now, let's imagine what your life would be like if you were an astronaut on the International Space Station. Now, for one thing, you'd be able to do some cool things there, like throwing boomerangs. Once, an astronaut threw a boomerang inside the International Space Station, and it returned to him. So, just remember, as long as there's some air, even weightlessness won't stop you from having a bit of fun. On the ISS, you would never have to deal with disgusting smells. There's a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs more than $10,000. That's why it costs less to throw your clothes away when they get dirty than to waste water on washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you'd get oxygen deprived. But what would you do on the ISS? Most likely, it would be space-related research. Astronauts on the station not only explore the possibility of future space travel, but also conduct all kinds of studies and explore the effect of microgravity on the human body. Oh, and speaking of microgravity, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit the Earth, and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means very small gravity. Earth's gravity on the International Space Station is only around 10 to 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Anyway, on your way to the International Space Station, you'd be wearing a bright orange spacesuit. Its color is called International Orange, and it has the same shade as the paint that coats Tokyo Tower in Japan or the Golden Gate Bridge in San Francisco. But once you reach the vast expanse of space, you'd swap orange for Snow White. See, the thing is, the orange suit is equipped with the stuff that can help astronauts survive if something goes wrong during the launch or landing of the spaceship. For example, a regular pumpkin suit has flares, medications, survival gear, a radio, and a parachute. As for the white bulky spacesuits, those are EVA, which stand for Extravehicular Activities suits. Their purpose is totally different from that of the orange suits. Astronauts put on EVA suits when going on a spacewalk. Such an outfit can protect them from the unfriendly conditions of outer space, with its extreme temperatures and the near vacuum. Besides, the white suit can prevent small debris from hurting space travelers. Oh, by the way, if you needed to scratch your nose while wearing your EVA suit, you would use a patch of Velcro inside the helmet. The lack of gravity also makes sneezing inside a spacesuit a serious problem. If you absolutely had to sneeze while on a spacewalk, you'd have to bend your head downward and sneeze into your chest. Otherwise, your visor would have to be equipped with tiny windshield wipers. Now in space, you'd often see random flashes of light, and those wouldn't be hallucinations. Cosmic rays hitting your optic nerve would create such an effect. You don't see similar flashes here on Earth because the magnetosphere doesn't let cosmic rays reach you. Before going to space, you'd have some underwater training. It's supposed to simulate zero gravity, but in fact, it has nothing in common with being in outer space. So the main purpose of this training is to see how future astronauts can deal with extreme environments. Oh, and later, during space adaptation, you might feel, well, let's say, weird. Around 50 to 75% of astronauts have highly unpleasant symptoms, such as vertigo, headaches, nausea, and overall tiredness. Luckily, everything usually gets back to normal within 72 hours. Before you were chosen to fly to space, you'd have to get through incredibly tough competition. According to NASA, they accept only 8 applicants out of 6,000. On top of that, the selection process takes around 18 months. Now, if you felt homesick on a mission and started crying, your tears wouldn't flow down your face. Instead, they'd gather into thick blobs of liquid around your eyes because the water surface tension would hold your tears together. You'd have to remember to attach yourself to something before falling asleep. Otherwise, you can easily float away from the spot where you went to bed and bump into a hard surface. That's why astronauts usually rest in sleeping bags in a small crew cabin. Another issue you'd have to deal with would be taking a shower in microgravity conditions, and it's not an easy feat. Astronauts use a shower in an enclosed cylinder which keeps water from floating away. They use a no-rinse shampoo, spray themselves with water to rinse off the soap, and finally use a vacuum hose that pulls inside all the water left on their body. You'd have to get used to a dramatic change in your diet. You'd have 3 meals a day, nothing outstanding here. But instead of sitting down to enjoy your lunch, you'd float around. Your meal would consist of some dehydrated and canned food items, and it might take a lot of time to finish it, since you'd have to be very careful not to let your food get away in the process. Now, imagine needing a haircut. After all, you'd spend no less than half a year on the ISS. To change your image, you'd have to use special clippers with a vacuum attached to them. You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours, jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermal quakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs. Now, there are things about nature that you know for sure, or don't you? Let's check how much you know about the incredible world we live in. How many of the 14 points will you guess? Let us know. The Great Pyramid of Giza was built when mammoths still roamed the earth. Myth or fact? It's actually a fact. The most famous pyramid in the world had been constructed about 500 years before woolly mammoths went extinct, approximately 4,000 years ago. Their last known habitat was the cold and deserted Wrangel Island in the Arctic Sea, which might not have been as cold then as it is today. There are more trees on Earth than stars in the Milky Way. Is it myth or fact? It's a fact. Scientists used to believe there were about 4 billion trees on our planet, but more recent studies have shown that there are over 3 trillion of them, making it 420 trees per person. As for the stars in our galaxy, there are only about 100 billion, which is 30 times fewer than the trees on Earth alone. The trees you see are all individual ones. Myth or fact? This is false. In fact, 90% of the trees on Earth are interconnected by mycelium filaments. They send warning signals when in danger and exchange nutrients through them. It's kind of like the underground internet. Also, there are organisms like Pando, for example, which is the largest single living being on the planet. It looks like a dense forest of quaking aspens. In fact, it's basically a single giant tree, with its roots being interconnected underground. We drink the same water dinosaurs used to drink hundreds of millions of years ago. Myth or fact? Actually, it is. Only a small portion of the water on our planet has evaporated for good. The rest of it is constantly renewed. So, mammoths, dinosaurs, and whatever came before them billions of years ago drank and swam in the same water we see today. Not to mention what else they did in the water. Unfortunately, the water doesn't keep information about those ancient creatures for us to find out more about them. Lightning never strikes the same place twice. Are you willing to bet on that? Myth or fact? If you aren't, good for you. Lightning may strike the very same spot as many times as it wants. It might seem random, but the electrical discharge from the sky is pulled toward the tallest objects in the thunderstorm area. Also, the material this object is made of matters too. It's by no chance that lightning rods on buildings are mostly made of copper and aluminum alloys. These metals are some of the most conductive materials, so they pull lightning very efficiently. All deserts are hot. Now, this one's easy, right? Myth or fact? If you guessed it's a myth, then right you are. Deserts are qualified not for their temperature, but for the presence or absence of growth and life in them. The most well-known desert is the Sahara, of course, and it is indeed very hot. The actual largest desert in the world is Antarctica, which is almost twice the size of the Sahara Desert. And you wouldn't call it even lukewarm. It's a polar desert, and there are several others on our planet. For example, Greenland. There's enough gold underground to cover the entire planet in a thick layer. Would you believe that? Well, you should, because it's true. Since 1950, humanity has mined nearly 200,000 tons of gold. If we made a cube out of all this metal, it would be 70 feet high and wide. Recent data from scientists confirm that there are huge reserves of gold in the Earth's core. The metal is enough to cover the whole planet, and people might have gold up to their knees. The problem is, we just can't mine it from there. Hey, I don't mine if you don't. The Moon and Mars are better mapped than the Earth's oceans. Now, this can't be true, can it? Actually, it can. We have a detailed map of the Moon and Mars, although we're still discovering surprises on their surfaces, granted. Still, over 80% of the Earth's oceans are unmapped and unexplored. We can't study the oceans properly because of pressure, cold, and lack of light underneath billions of tons of water. The lava is always red. What other color can it be, right? Myth or fact? Myth. Usually lava is really red or orange because it's basically molten rock from the deep bowels of our planet. But there's one volcano in Indonesia whose lava is blue and luminescent. Only at night though. During the day, it looks normal. No mystery about it, just tons of sulfuric gas. This volcano also has the largest acidic crater lake in the world. The water there is so turquoise, you want to jump in immediately, but you probably guessed you should never do that. The fire on that volcano is also blue, the largest blue fire in the world, rising up to 16 feet high. Ever seen a gas stove burning? Here, the principle is basically the same. You can see a rainbow at night, too. Is it myth or a fact? It's true, and there's even a name for this phenomenon, a moonbow. Also called a lunar rainbow, this event occurs extremely rarely. It's similar to a regular rainbow, except when it appears on a clear moony night after a rain shower. There's a thing called a fire rainbow, myth or fact? You bet! It's a beautiful phenomenon when the clouds in the sky are painted all the colors of the rainbow, looking like a fiery, multicolored cascade. It only occurs when the conditions are right, and those are very specific. It's close to the equator, the weather is clear, there are feather-like clouds in the sky, the sun is higher than 58 degrees above the horizon. Such clouds are made of ice crystals. When the sun's rays hit them, the particles refract the light and create a rainbow. Wow! There are rainbow trees. Myth or fact? If I made you doubt this, I'm glad, because this one is not photoshopped. This is the rainbow eucalyptus, and their bark may literally have all the rainbow colors. These eucalyptuses shed their bark at different times each year. Every time the old section goes off, the tree first reveals bright green bark that was hiding underneath, and then it may turn any color. There's a whole set of hues: orange, maroon, blue, even purple. Stones can move on their own. Myth or fact? Well, you'd be right to believe me. There's a desert plain in California where rocks move around of their own will. Once this plain used to be the bottom of a lake, but then it dried out and became an arid wasteland. Sometimes rains fall here, flooding the entire valley. When night comes, the temperature drops and the water is covered with a thin layer of ice. When it gets warmer again, the ice breaks into segments and the wind pushes them around the place. Some of these ice shards take small rocks with them. When the ice melts for good and the water evaporates, the only thing that remains are trails left by the rocks, as if they'd moved on their own. Mud puddles can move around. Myth or fact? In fact, a single mud puddle in the world also travels as it wants, and nobody still knows why. It moves at a pace of about 20 feet per year, and it seems to have started its journey near the San Andreas Fault in California. People have tried to stop its march, but couldn't. So far, this creeping natural disaster isn't showing any signs of stopping on its own either. So, there's your pesky, problematic puddle to ponder. Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the sun until, bam! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, Our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the Moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England Highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed 2 enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
The Grand Canyon in Arizona is bigger than the state of Rhode Island. You could even fit the whole of Manhattan in there. It's so massive, it kind of has its own weather. But the Grand Canyon isn't the only big crack out there. The Valles Marineris is bigger, way bigger. It's on Mars, and it goes nearly a quarter of the way round the planet. It's 10 times as long as the Grand Canyon, and it's so deep, you could parachute into it. The Kesai Valles is also on Mars. It's made up of a series of canyons, and it might be the ancient home of a massive Mars flood. There are huge canals and canyons all over the red planet. There's Tiu Valles. That's where researchers think there was an epic battle between ancient Martian water and boiling hot volcanic lava. Guess we know who won that one. Equally impressive is Ares Valles. It's the longest known drainage system around. It might be weird to think of Mars as having huge waterways, rivers, and floodplains, but in its early days, Mars might have had a warm and wet climate. Now it's just dried up canyons as far as the eye can see. The Ithaca Chasma looks like a giant scar on Saturn's moon Tethys. It's 4 times longer than the Grand Canyon and about 3 times as deep, and it's billions of years old. No one's been kayaking there yet. We've only seen a photo of it, thanks to the spacecraft Voyager 1. Mercury's Great Valley makes the Grand Canyon look like a tiny pothole. NASA's Messenger spacecraft was the first to snap some photos of this massive formation. The valley's surrounded by 2 giant somethings, the Enterprise and Belgica, whatever that means. Pluto's largest moon, Charon, has a canyon named Argo Chasma, and it's huge. Even though Pluto's not called a planet anymore, it can still brag about its huge canyon. Even right here on Earth, the Grand Canyon has some serious rivals. Yarlung Tsangpo Canyon is the deepest canyon on Earth. It's in the Himalayas, in Tibet. Some people call it the Everest of canyons. You could fit a 2,000-story building in it. The Indus River Gorge is big and gnarly. It's in Pakistan, and you could stack 3 football fields inside it. The Indus River, one of the largest rivers in Asia, passes through it, and it's even home to baleen whales and porpoises. The Colca Canyon in Peru is a short but insanely bumpy bus ride away from Machu Picchu. It's the massive home for the largest flying bird in the world, the Andean condor. It has a wingspan of 10 feet. In Nepal, where the Himalayas are, is the spectacular Kali Gandaki Gorge. No one knows exactly how far down it goes, but it's probably around 5 times as deep as the Grand Canyon. It's got it all: crazy terrain, thin air, and it's in the middle of nowhere. So beware, only experienced hikers should dare go in. The Copper Canyon in northern Mexico is home to a world-famous group of people who run marathons or even double marathons just for fun. There are 6 canyons all joined together, and in its widest part are 2 of Mexico's tallest waterfalls. Copper Canyon also has one of the longest zip lines in the world and one of the scariest train rides you'll ever take. Don't look down. Even in the US, there's a lesser-known canyon that's deeper than the Grand Canyon. It's Hell's Canyon. And it's sort of on the border between Oregon and Idaho. It was carved out by the Snake River. Hell's Canyon is home to the Seven Devils mountain range. The Kings Canyon is in the Yosemite National Park area. It's about 1.5 times as deep as the Grand Canyon. Nearby is the second largest tree on Earth, General Grant. The largest canyon in Australia is the Capertee Canyon, and you can get paid to go there. Sort of. A few lucky cyclists and campers over the years have found gemstones on the banks of the Capertee River. If you're lucky, you'll also see some 2,000-year-old rock art. The Tiger Leaping Gorge is right out of a fairy tale, but it's very real, very deep, and pretty scary. The legend says that a tiger was being chased, and it leapt over the river at the bottom of the gorge, with a little help from a perfectly placed rock right in the middle of the river. The Great Rift Valley is 15 times longer than the Grand Canyon. So what, that's like 1 trillion miles long? It goes through 2 continents and is home to about 30 lakes. It's even visible from outer space. So if you're ever floating out there in the cosmos, keep an eye out for it. The Cotahuasi Canyon is deep, very deep. It has extreme rafting, kayaking, and hiking. And apparently the mosquitoes are pretty extreme too. There's one canyon in Tibet that I'm pretty sure holds a world record. Try looking up the Polong Tsangpo Canyon. No images pop up. It's 2021, that's insane. What's down there? Yeah, probably just a river and stuff. Colombia's Chicamocha Canyon is pretty much as deep as the Grand Canyon. Extreme sports own this place. Ziplining, canoeing, paragliding. Heck, even their cable car is extreme. It's a 25-minute ride, and it's steep. Under Greenland is the Greenland Grand Canyon, and it goes for hundreds and hundreds of miles. Water from melting icebergs runs through the canyon. It was actually NASA who discovered it. There's an absolutely massive canyon in Antarctica. The only problem? You can't see it. But apparently, it's freezing cold and mostly white. The sea has some mighty canyons too. The Jemchug Canyon is one of the biggest underwater canyons. It's right off the coast of Alaska, and it's home to seals, dolphins, and whales. The deepest underwater canyon is about 6 times as deep as the Grand Canyon. It's the famous Mariana Trench. Make it to the bottom, and you'll break the world record for deepest dive ever. The Grand Bahama Canyon is another underwater marvel. You could just keep dropping Empire State Buildings in there, and you'd never see them on the surface. Monterey Bay is pretty laid back, but its canyon is anything but. There's lanternfish, squid, sea turtles, rockfish, and sea otters all hanging out together. Oh, and thousands of jellyfish, so take care not to get stung too much. There's also giant kelp around there, a seaweed that can grow up to 100 feet long. The Hudson Canyon runs from the New York Harbor right into the sea, and it's gross. Sure, it has deep sea coral and sponge formations, but it also has a whole bunch of trash and sewagey sludge coating the bottom. The Aviles Canyon is off the coast of Spain. It's one of the deepest underwater canyons in the world, and it's one of the few places where giant squid live. It's famous for its white coral and the fact that it's insanely cold. Bremer Canyon in Australia is underwater, massive, and dangerous, especially if you're a giant squid. That's the favorite snack of the local orca, the huge whale with a monster appetite. Bremer Canyon's a major tourist destination these days, especially for those looking to snap a pic of the more than 100 orcas that call it home. The Nazare Canyon is near Portugal. It's the largest submarine canyon in Europe, and it's around 3 miles deep. That's 6 of the world's tallest buildings. It forms high breaking waves, so it's become a haven for big wave surfers. The Canadian Arctic Rift System is huge. It goes all the way from the Labrador Sea to the Arctic Archipelago, and it connects the Arctic and Atlantic Oceans. So, picture this. Greenland used to be smashed up against Canada some millions of years ago. Thanks to this rift system, Greenland's been slowly drifting away. Think how huge Canada would be if you added Greenland onto it. It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.